Hello friends, today I'm going to talk about Leetcode 1143, longest common subsequence. The problem is that given two strings, text1 and text2, return the length of their longest common subsequence. The definition of subsequence of a string is a new string generated from both strings with some characters deleted without changing the relative orders of the remaining characters. And let's say some example here. The first example that we have A, B, C, D, E, and another text is ACE, and so we have the longest common subsequence is ACE because ACE is from the text 1, and also the ACE is from text 2, so they have the uh, common sequence that has length 3. So the common subsequence is not a continuous subarray. It could be disconnected. And the second example is that we can see the ABC and ABC, their cause is 3. And the third example is ABCDEF, they have no common subsequence, so the result is 0. Let's look at the example to figure out how to solve this question, and we can see that A, B, C, D, E vs A, C, E, and this is actually a very classic dynamic programming because it satisfies the two properties of dynamic programming. First, it has the overlapping subproblems. And like here, if we use A, B, C, D, E vs ACE, and it also has a subproblem as B, C, D, E vs ACE, or CD vs ACE. This is a subproblem of this big problem. So it has subproblem properties. The second is that whether it is a subproblem have the optimal substructure property. If it has optimal substructure, it can be solved with dynamic programming. Yes, it has this property like the A, B, C, D, E, and vs ACE. It can transfer to another subproblem B, C, D, E vs CE. And we know that this A equal to this A in the second way. So if we know this answer of BCD vs CE answer, and then this answer should be the one more of this answer, and also if we know that the optimal solution of the substructure has a solution that is actually an optimal solution, so we can solve the big problem and also get an optimal solution from the substructure's optimal solution. So it has the property of optimal substructure. Then it can solve with a dynamic programming. So for dynamic programming, there are two ways to solve this, as I have the videos about how to solve dynamic programming. If you want to look at more, you can look at my videos about the dynamic programming series. For dynamic programming, we know that we can most of the algorithm can solve with the top-down memorization, or the second is the bottom-up tabulation. And let's look at how to use the top-down memorization to solve this question. And we can know that A, B, C, D, E vs ACE. We know that A in the array here. Mm, Here A with this A is the equal. So we can have the answers about mm, the subproblem. For example, we define subproblem as a help function. Then with the BCDE with ACE and with CE, right? And the second option is that is that possible that this if this is not equal, and if it's not equal, we could have to compare the A B C D with CE. And so we get the help function here. And also the third option is that we compare BCD with ACE, right? So there are three options in for this problem. So we will get the max of these three problems for this problem for this question, and so we get the max of these three. So basically, this is the idea of the recursive function, and if we look top down. And I didn't mention here is that because here there is we can use an index to indicate the next element here. Here is BCD, and it's we get from the second element, so it's the index is +1, and CE the second index, and so it's +1 again, and ABCDE here is index still the same as the previous index, and CE is index +1 again. Here is the index is +1. For the second array, this index is the same. So we can use the index to decide which element to choose. And secondly, for top down, we can have to consider the base case. The base case, if the index equal to the last the length of the both actually it's any one of them. If the index for example index 1 is for array 1 is equal to the length -1, or the index 2 is equal to length 2 -1. That means we have traversed to the end. So then we return 0 here. I think this is the basic logic of the top-down memorization. And secondly, we consider the bottom-up top tabulation. For the bottom-up tabulation, that we have to consider first define a function about the about the state of the problem. So here the state is that indicate that the longest common subsequence when we traverse that indexed I for text 1 and index j for text 2. Then we define the transition function. The transition function should be the maximum of these three cases too. The first case is that if I and j in text I, text j, I minus 1 and j minus 1 is equal, so we plus 1. Now here is a, b, c, d, a, c is a is equal, this I minus 1 is we can say that current I and I is the same, so we consider the previous one, and directly add plus 1 here. And the second case is that if it's I minus 1 and j, and third is I j minus 1. And then what is the initialization here? In the initialization is everything is could be the 0 for the first, and we have to know that I and j should in that I in 0 to the text one's next, and j is in the 0 and text to the next. And let's use a test case here. For example, a, b, c, d, e. Let's construct the tabulation here. For the dynamic programming, we can construct tabulations for the bottom-up method. So a, c, e, and we initialize the index from the 0 to length minus length. So the length, so the length is one more than the text one length, and we initialize 0 and when there's empty here, this is not empty array, and this is also an empty array. When it's empty, we know that there's 0 common subsequence, and here is 0 here, 0 here, and then we consider to fill in this table. How to fill in the table? We know that if a and j equal to 1, so we know that we should call this function here. Maybe I can, it's better to change this one, text 1 I minus 1 equal to text 2 j minus 1. So we consider this. Other case, we consider the two cases, and here this is satisfied, a and equal to a here, so it's this 0 value plus 1, so it's 1 here, and then so it should be here. Here is 0 here, sorry, and here should be 1 plus this 0, and then we compare the a and b, they are not equal, so we go to one of them to max, so it should be 0 or 1, the max of them, so it's 1, and here is we get 0 and 1 max again, because a is not equal to c, so it's 0, 1 again, and here is 1 again, and so on, it's also 1, and when we go here, a and c is not equal, so we get the maximum of this the 1 or 0 here, so it should be the 1, and here should be the 1 again, and here is C and C is equal, so we get the use this equation, then we get it 1 plus 1, so here 1 plus 1 should be 2, and then C not equal to D, so get the maximum of the 1 and 2 here should be the 2, and then we get maximum 2, and here then we get A and E is not equal, so we get maximum 0 and 1 is 1, and 1 again, and 1 again, and 1 again. Now we get E and E, they are equal, so we get the maximum 2 plus 1, so here is 3. So finally we return the TP length 1 and length 2, length 1 and length 2 as the answer. That means that we have traversed length 1 and length 2. So for this, it takes about O length 1 times length 2 times complexity, and space is also the same as this length 1 times length 2. Let's write the code. Here I'm going to write the bottom up tabulation method, and let's get the length of text 1. And we initialize the longest common ancestor. Then we traverse from the 1 to the m, because we have initialized the zeros for when I equals 0 for the first row, and now the first row here, and also we initialize the first column here, like this. This first column, so j equals 0. So we don't need to traverse from when is I equals 0 and j equals 0. We need to traverse from I equals 1, from traverse all of this. So I equal to 1, and also j equal to 1 to m. Then we check the text 1 I minus 1 equal to text 2 j minus 1. If they are equal, we know that we have to plus 1 of the previous sub-problem's answer, j I minus 1, j minus 1. Otherwise we get the max of them. We get two options of the maximum. The maximum finally we return answer. We have to return the dp m times n. Or something wrong here. This should be the m plus 1. Yeah, we made it. Thank you very much for watching. See you next time.